Okay, so welcome back. Now we're going to do some examples of rounding. Okay, so when it comes to multiplication division, the rounding is very different than with adding and subtracting. So instead of dealing with precision, when it comes to multiplying and dividing measured numbers, we're going to talk about accuracy. We're going to look at the accuracy of the individual numbers, so the products or the numbers we're dividing, okay? The factors, I mean. So in the divisional numbers here, so in this case, we're going to look at the accuracy of the numbers. And so very similar to when we dealt with adding and subtracting, where we deal with precision, we wanted to make our answer precise to the least precise number that we're dealing with, that we're measuring. In multiplication division, it's with accuracy we're going to look at. So we want to make sure our answer that we're calculating is accurate or as accurate as the least accurate number. Okay, so that means we're going to be dealing with significant digits, right? Not place value or decimal places. So in this case here, for example, we have these two numbers we're multiplying. Now, in this case, we have 3 significant digits here, and we have 2 significant digits here. So we're going to round our answer to 2 significant digits. So what we're going to do is we're going to multiply as we did before, and then at the end, we'll round to 2 significant digits. And the way we do that is our significant digits is always left to right, okay, the way we read a number. Okay, so here we're going to just multiply, so it's going to be 4.35 times 3.6, and of course this is going to be square feet. And when we do that, we're going to get, what answers are we going to get? We're going to get 15.66. So that's going to give us 15.66 square feet. And so now we're going to round this to 2 significant digits. Well, 2 significant digits, again, from the left to right is going to be the 5. So we're going to round, in this case, we're going to round to the nearest foot, or square foot. So this would be approximately equal to 16 square feet. Okay? Now, what about this one here? So again, look at the significant digits of each number. So this is 3 significant digits, this is 2. So again, we're going to round this answer, the quotient, we're going to round to 2 significant digits. So we're going to divide first, right? So we do 375 divided by 65. And then of course, let's figure out what our units are going to be. Well, we have miles. Oops. We're going to have miles, I'll put that over 1. Times, or no, divided by what? Miles per hour. So this is going to be miles per hour. Now, I'm going to change this. See, I'm going to use the same thing that we did with numbers. I'm going to change this to a multiplication, but if I do that, I have to take the reciprocal of the fraction here. So this is going to be then changed to hours per mile. And now notice that miles cancels with miles, and I end up with hours as my units. Okay, so now that means my final answer is going to be hours. So now what's my calculation? Well, if I put in my calculator, I'm going to get 5.7692 and so on. 5.7692 and it keeps going. So 5.7692 and this is going to be hours. Let me just double check that. 5.7692. Okay, good. Now, I want 2 significant digits though, right? Because again, the least accurate number is going to be the 65 miles per hour. So I want mine to have 2 significant digits, which means I'm going to round to the nearest tenth of an hour. which means I'm going to round it up to approximately 5.8. So this is going to be approximately 5.8 hours. And that's the answer. Now, what about an application one? So let's talk about machine trades. So let's say we have each inch of cold rolled steel weighs 0.22 pounds. Okay? So each, each inch weighs 0.22 pounds. Okay? And a certain job calls for 27.5 inches of steel. And the question is, how much is all that going to weigh? Well, each inch weighs 0.22 pounds, and they want 27.5 inches. So what are we going to do to find the total weight? Well, we can add each inch and then add the weight of the half of an inch at the end, or just multiply, right? This is multiplication all the way. So we're going to multiply these two. Okay? So now here's the thing. How do we write this weight here? Well, it's 0.22 pounds per division per inch, right? So the weight of the cold rolled steel is 0.22 pounds per inch. Don't forget that, okay, the context. So now I'm going to multiply this. So this is going to, again, I'm going to multiply the numbers first, right? So I'm going to do 27.5 times 0.22, and that gives me 6.05 pounds. Okay? And you could do it in your head, just realize that I'm doubling this, right? If I double this, this is 55, right? If I double this, it's 55, but it's going to be 5.5 because of the decimal place, right? So it's going to be 5.5. And then it's going to be another double here, but again, it's 2 decimal places, so it's going to be 5.5 plus 0.55, which gives me the 6.05. Okay, and this is going to be what? Now the units. Now I'm multiplying. So it's going to be pounds per inch times inches. So I'm going to put inches over 1. Right? And so now cancel inches, and I end up with pounds. So my final answer is 6.05 pounds, but look at the accuracy. Okay, this has 2 significant digits. This has 3 significant digits. So we're going to round this to 2 significant digits. Well, where are the significant digits? This is a significant digit, and this 0 is a significant digit. Why? Because it falls between 2 non-zero digits. So what we're going to do is we're going to round to the nearest tenth of a pound. So this would be 6.1 pounds. Okay, so the answer is going to be approximately 6.1 pounds of steel. Have a great day.